All right, let me just open in AutoCAD. I have some drawings over here, okay, related to bridge and maybe culvert, okay. And this, as you can see, this is a abutment and then wing walls. So, as a quantity surveyor, you must be familiar with drawings and terminologies related to different engineering structures such as building, bridges, okay, canals, etc. So because those things are then included in description, okay? Let's say if this is abutment and wing wall. So a quantity surveyor should be familiar which one or which part is just abutment and then which part is just called or known with the or by with wing wall, okay? So this is just a single diagram, you can say. And here we have the, of course, the cross section, okay? Everybody just understand this. And on the other hand, as you can see, we have this bridge, which is, you can say, just RCC bridge, having slab, then the wearing court, some grills, okay, or posts, and you can see this. This is a like a T beam, okay, and percentages are also given in each member, okay, like you can say mild steel and beam. This is 2.5%, okay. So we will be just looking into these two examples. We are in the first stage, we will actually determine or we will prepare the abstract of quantities for different materials used in the same diagram, you can say, okay. And then we will switch into the bridge, you can say decking, which is the same thing, and we will actually determine quantities of materials, and then of course we will include cost as well. And I'm not going to do this in whiteboard. We will just do it in a Excel sheet because whiteboard can take much time. So let's just say if I have, it is the same thing, okay? I will say serial number because we do this all the time. So then description, okay, and then we have the numbers, then we have the length, and then the width of breadth, height, and then of course the quantity, and then we have some remarks if we need, okay. Now this is actually the table which I'm gonna call is, let's say, abstract of quantities. It's your choice if you can do some, you can give it some styles and coloring, maybe shades, etc. I'm not gonna do that because the video can get longer, which I actually do not want. Now, however, you can adjust the columns width and some other stuffs. That's your work. So the first thing which I'm going to do is actually, let's just look into the same diagram, which is this one. Here, as you can see, we have abutment and then wing wall. So let me just say if I have, let me just change the color. You can see the red one, okay? Now, in the same diagram, these are actually known by the wing walls, okay? These, right? And the middle thing, which is this one, this is actually the abutment. Now, abutment is actually the support of a bridge or maybe culvert, and these are actually the exterior, okay? Or you can say the supports at both ends. Now the middle supports are then known by the pier, maybe, okay? So I guess you guys note those things. All right. Now, in order to calculate quantities of different materials and which quantities are just included in the same section, you can see them, okay? We have excavation because the ground level is just labeled over there. And then we have actually concrete, 136. And then it is a brickwork because this abutment and wing wall, these things are just, you can say, for a small bridge or maybe culvert, okay? So brickwork, which is pretty good thing, or maybe any masonry work. So let's say the first thing which I'm going to do is actually to calculate the earthwork. Okay, you can say excavation, and let me just label as 1. And then I'm going to say the earthwork, or maybe you can say excavation. It's your work. You can just have anything in description. Now, in earthwork, as you can see, we have abutment and then wing wall. So I would say that first I'm going to calculate abutments excavation, and then I will look into the wing walls. Now, in number, abutment is 1, wing walls are 2. How? You can just see it, okay? Wing walls, these are actually 2, One is this one, another one is this one. Now abutment, which is this one, and that's actually one only. The excavation length, if you remember, we have already discussed these things in very first, third, or maybe three or maybe four lectures, that the excavation length is somehow very different, okay? Now, the abutment length, as you can see, this is 20 feet, which is already just mentioned were there. From this, let me just draw a rectangle so you guys can see it. You can see this one, okay? It's almost like this thing. So this is, if you look to in top, this is actually 2 feet wide, and the length is just 20. However, we will just have excavation till this point, okay? Till you can say, let me just drag this thing so you can see that, okay? Excavation length can be up to this. What do you say? It's very simple, okay? It means we have to add 2 feet, which is actually, if you see, this is 2 feet, okay? And let me just label it so you guys can um, then confirm it, and can be very easy, okay, for you. So this is actually 2 feet. We're here, okay? Just clicked on the wrong place, and this is, you can see it, it is just 2, okay? So what should be the length of excavation for the same abutment? It can be actually 20 feet, and then 2 feet for one side and 2 feet for another side. You can see these two things, okay? And then here we have 2 steps extra, and 2 steps the other side, okay? It means if I can directly say the length of the abutment for the excavation can be 26. Now, how 26? That's the point which should be cleared over here, okay? So 26, I'm gonna write this thing in the remas, but before writing this in remas, let me just make you understand, and I want you guys to confirm it, okay? Now, just look at over here. I'm gonna say, let me just have some maybe dimensions, okay? Now, look at this. This is 20, and from this, as you can see, we're gonna add 2 for one side and 2 for another side, okay? Now, next, I'm gonna add these 2 steps, okay, which are actually, you can see, this is 1 feet. It means 6 inches one step and 6 inches another step. And to the other side, which is actually 1 feet, it means 6 inches to one step and 6 to another step. Now the total is actually 20, and 2 for another side, and 2 for this side. Actually, it means 24, 1 feet this one, 25, and 1 feet this one, which is 26. What do you guys say? Okay, so it is actually, if you are a little bit good with drawings, so you can do that. However, if you're not that good in drawings and you cannot read these things, the plans maybe, okay, sections, elevations, then, if you remember, I have already told you a formula, okay, about a formula. It is actually, you have to subtract the weight of the wall, which is 2 feet, from this, okay, from the weight of the foundation. So it means 4 minus 2, okay, this is actually 2. And then you have to actually add this with the length, which is 20 plus 2 plus 2, 24. So 24 plus 2, that's going to be 26. Okay, I'm going to write this thing over here, like maybe what is 26? Okay, so it is actually the same thing like 20. Okay, we have just added 2 feet for the wing walls, okay, for one side, 2 feet for another side. And then if you remember, we have added 1 feet, okay, for one side, for you can say for 2 steps, and 1 feet for another 2 steps. What do you guys say? And in the width, actually, this is simple. Width is very simple. You can see the width can be from this point till this one, which is 4 feet. And if you cannot just count this, you can see it in the section as well. The weight of foundation, which is 4. So you can put 4 over here. And now another thing, which is actually height. And this is actually the height of excavation, and where we do actually excavate, and from which level we actually excavate. It is actually the ground level. So we have to count all these heights below the ground level, which is actually 1 feet and 2 feet and then 2 feet, which is actually 5 feet, okay, total. So we have 5 over here. Now, the quantity can be actually, we have to multiply these things. Okay, you can say the
Okay.
number, the length, the breadth, then the
No
height, which is
interview.
actually the quantity. Very
Final
simple.
interview.
Okay. So the number, the length, okay, lage bande kya kaun hai ye banda? The weight and then actually the height, which is F4. Okay, so I'm gonna multiply that F4 as well. So 520, and I'm gonna just enter another column over here so we can have per unit. Okay, maybe let's say units, and this is going to be in CFT or maybe cubic feet. So we have quantity, which is 520. Now let's talk about the wing wall. Now I'm going to say the length can be 6 feet. How? That's going to be very simple. You can see it, okay? We have 6 feet is the length of the wing wall, okay? Now, the total length of the wing wall, that is actually 6 feet. You can see it in the diagram, okay? But this is actually from this point till this. Why are not we actually adding this portion, which is, you can say 2 feet? Sorry, 1 feet, because one is 6 inches and another step is 6 inches. Why are not we taking 7 feet as the length of the wing wall, you can say? And this is actually because, okay, let me just say, I'm not taking this portion because this portion is already taken over here with the abutment. What do you say? These two steps are taken from the wing wall. So if we add these two, it means we can subtract those two. Very simple. So actually it is the same thing, okay, from this point, okay, from this point till this point. So it is the same thing as 6 feet, okay? We are not counting this one, okay, actually. So it means 6. Now, of course, the weight of foundation, it is the same, which is 4. The height is the same, and we can actually drag the formula just like that, okay? So this is the quantity. Now, total can be actually the summation of the above two. So we can say the total quantity may be, let me just merge these. So the total earthwork for abutment and wing walls. Very simple. You can even, and actually you should highlight these things, okay? And I'm gonna remove that one so we can have yellow. So this is one thing which is been covered. Now, next, what we're gonna do is actually to determine the concrete work. And why I'm deciding concrete work, because in this section, we have excavation and then over here we have concrete work actually, which is 136. So let's say concrete work, and which is 136. Now, the concrete work actually can be the same for both, okay? In, you can say, in depth and then in width. The length can be different, of course. So we're going to calculate this for the abutment and then wing wall. Remember, abutment this time is 1, wing walls are 2, okay? And the length of abutment, it can be the same. Why the same? Actually, if you see the foundation width, it was just 4 feet. Now the concrete work, it is also 4 feet wide. That means the length of both quantities or maybe both elements is just the same thing. This is the reason I'm gonna say that the length of the abutment for earthwork is the same thing as the length of the abutment for concrete work. Okay, and this is the same thing for the wing walls. Now next, actually the width or maybe the breadth, it is the same thing. Okay, in PCC you can see that, so it's gonna be 4. However, the height for both, it is just something which is different. Okay, we actually take the height or maybe the depth of earthwork from the ground level. This time actually the concrete is only 2 feet, if you see that. So the height is just 2 feet and 2 feet for the wing wall as well. Now I'm gonna just copy the formula over here and we have to just paste it, and then let's just drag this formula below. Now we will actually sum the above two, which is CFT, okay, 304 CFT. That means this is the total. Let me just copy this thing and paste it over here. So it is the total, maybe PCC or concrete work, 136, okay, for abutment and wing wall. And let me just share these as well. Okay, it's very simple. Number 3, we have actually number 3, and it can be in this section. If you see, we have this step, which is actually, of course, the brickwork or maybe masonry work. And then we have another step, which is this one. Okay, so two steps, you can say brickwork. Okay, so again, jumping into the Excel, it means, let's say we have the brickwork and it is in 1:3. 1:3 is actually the ratio of mortar which is then used in the same brickwork. Now, I'm going to say the brickwork, okay, for the abutment, and then I'm going to say it for the wing wall. However, in abutment, if I'm going to talk about the abutment, there are two steps, okay? One is actually this one, another one is this one, okay? So we have to take two steps, and because of that, I'm going to say step 1 and then actually step 2. You can also just label these things in the same Excel as the brickwork below ground level and then the brickwork above ground level. So as your work as a quantity surveyor, you should consider all these things. And I'm gonna say again, let me just call this guy is A, okay? And over here, I'm gonna copy those things and paste them over here. And I'm gonna say B is the wing wall. So we have actually step 1 and step 2 in wing walls as well. Now, abutment. If you remember this step 1, let's just jump into the AutoCAD. As you can see, this is the step 1 whose width is just 3 feet. Now, what's the formula? You have to just subtract actually the width of the wall, which is 2. So 3 minus 2, that is actually only 1. Now we have to add the length of the abutment, which is actually 20 and 2 for one side and 2 for another side, which is 24. So 24 plus 1, that is 25. Very simple. So the length of abutment is just 25. And I'm going to actually, this is for step 1, right? 25. And let me just actually annotate that for you so you guys can be very clear about this thing. Okay, remove those things which are actually some extra work. Now, I'm going to have the dimensions. Now, step 2, if you see, it is from this point. Okay, I'm going to label this from the that point till this point because this is also step 2. Now, you can see it is actually the dimension 25. Very simple. Out 25 in remars, you can just put 25 is actually something which is 3 minus 4. And you can also actually, if you remember, we're here, yeah, it was actually something different. Okay, you can also just mention 26 is maybe, let's say, 20, okay, plus 2 for one side, 2 for another side, okay, and then actually adding the thing which is maybe you can say 4 minus 2, okay, and this is actually the same thing, okay, that is not equal, that is actually 20. So 20 plus 4, that is 24, and 4 minus 2, which is 2, 24 plus 2, it is actually 26 again. It is the same thing over here, okay? It is the same thing over here for this thing. Now, 25 that can be just written in remas is, you can say, again, 20, which is the maybe the distance, the clear distance between two wing walls. And we're going to add 2 feet for one side wing wall and 2 feet for another side wing wall, okay? And then again, that formula, okay? It is actually 3 minus 2. Okay, 3 is actually the weight of the step 1, and we are subtracting 2, which is the weight of the abutment. So 25 should be. Now, what is the weight of the same wing wall, you can say, in the same step? That is 3 feet. So you can put 3 over here. Now the height. Let's just jump into the AutoCAD so we can see the height. The height is 2 feet, you can see it. So 2 feet over here. All right, and number actually that is 1, and we have something mistake over here, like you can say. And number that is 1. For step 2, that is also 1 because this is abutment. However, this is 25, which is the length. The weight is 3 and the height is 2. So this was actually the mistake, but you guys can see it. You guys are sleeping, I think. For step 2, these two things are different, actually, the length and the height and maybe the weight. Let's just confirm them. Okay, you can see that these are actually different. It is 2 feet wide, you can say. The height is 11 feet. Okay, and then the length can be different as well, because it is from that step. You can see it. Okay, it should be 20 and adding only 2 feet to one side and 2 feet to another side. It means this can be 24 if I'm not wrong. Okay, from this point actually till that one, you can see it is 24. So a number that is 1, the length is 24, the width is actually 2 wide, and the height is 11 if you see. We have to copy the formula and paste it over here, and I'm going to drag that one. Okay, so this is now actually the quantity of brickwork, okay, for the abutment. Now for the wing walls, actually step 1 can be 2 in number, step 2 can be 2 in number, because wing walls are 2. Now the length, what should be the length? 6 minus 1 step maybe. Okay, let's just see if I'm right or not. Okay, so step 1 is actually, if you see, this is 6 feet. Okay, and it should be actually, you can see it, maybe let me just say linear. This is step 2 from this point till that one, it is 6. Okay, and again step 2, I'm going to take that in advance, that is 6, and over here it is 6 again. That means these are like short walls. If you remember long wall short wall method, we have already discussed these things in detail. So what we have covered in that time, actually the length of the long wall can be actually a little bit more than the actual length for each step. However, the short walls remains the same in length. So this is the basic concept, if you guys remember that. The length is 6 for one and 6 for another step. Now, the weight can be both actually the same, because the section is just the same for both abutment and wing walls. And the height is actually the same for both. What do you guys see? And I'm going to apply the formula. So you can drag that to step 2, and then let's just add all these things. And this is actually the summation. It is 1014 CFT. Very simple. So it is actually the total, maybe let's say I'm going to copy this, the total brickwork for abutment and wing wall. So let's say total brickwork for abutment and wing walls. Very simple. Is there any question?
Yes, sir.
Okay. What is it?
सर ये ग्राउंड लेवल से ऊपर ये 1 फीट का एस्टिमेशन हमने नहीं दिखाना है.
एक second. Let me see. Oh, and below, it is actually below the ground level. And for
Yes,
step 2, as you can see, it is 11 feet. Okay, for step 2 is height. What do you see here?
yes, sir. ठीक है.
Yeah, it is clear. Now, next, actually, what we do is the pointing or maybe the plaster work for the brickwork. So we will only consider the things which are maybe above the ground level. Below the ground level, we will not consider that. If it is required, or maybe according to the drawing and according to the tender, so you have to just count them. This time, I want the video to be shorter, so I'm gonna take only the things which are very easy, I mean, just both sides of the wall and above the ground level. So the height can be actually 10 for this time, okay? Because we will subtract this 1 feet. So the height can be actually only 10 feet. So let's just say the plaster work, and this is number 4. And I'm gonna say plaster work, okay? And slash maybe pointing. So one of these two can be taken. I'm gonna say, okay, let me just add some other informations, like maybe both sides of walls, which is abutment and wing walls, you can say. And then I'm gonna say above the ground level. Very simple. Wrap the text so you guys can see it in the same column. One thing is actually, I'm gonna consider, let's say A is abutment, and then B is wing walls. Now in number, it should be 2 because we are pointing or maybe plastering both sides of the wall. In wing walls, okay, these should be actually, and one another thing, okay, let's just jump into the same thing over here so you guys can be very clear. So if you look to the same diagram, we are actually plastering above the ground level, which means we will look only into the step 2, okay? So for the wing walls, we are actually plastering both sides, and for the abutment, we are plastering the both sides. But something which is really wrong over here is actually, let me just copy these things so you guys can see it. Okay. Let's just say, and I'm gonna explode this one so you can see it graphically. Okay. Now in the wing walls, I can only just, you can say, let me have some color. Okay. In the wing walls, these green areas can be plastered. For the abutment, these two can be plastered. What do you guys say? It's gonna be very simple. If I say that both sides of the wing walls, okay, or maybe both sides of the abutment, it can be very wrong because we have some extension for the outer side, like you can say date extension. Okay, so that is something very, you can say, lengthy. So what best here is you have to take the parameter and then multiply that parameter with the height, which is actually maybe 10. Okay, because we are subtracting that 1 feet, right? Very simple. So I'm gonna remove that 2 and let me just say 1 instead, and let me just remove that one and I'm gonna say abutment, or maybe I can even include that over here. Okay, abutment and wing walls. Very simple. Okay, so in number it is 1, the height is 10 feet, and I can even just delete this raw now. Okay, because I supposed to make you guys sure about this, what I'm gonna do here now. Okay, so what should be the length and height, or maybe the thickness, that is just ignore because we didn't consider that while doing analysis, if you remember from maybe 6th and 7th class. Okay, so during analysis we then include the thickness of plaster. Okay, so let's see what's the parameter now. It is actually 20 plus 2 plus 2. Okay, for that side. So that's gonna be actually 24. Now this is 6 plus 2. Okay, you see it. I can even remember them, which is 8. Now this portion is 2. Look, I remember it. So as a quantity surveyor, you should be that familiar with drawings, so you guys can even consider things, okay, before even looking into the drawing or maybe just counting the digits. Okay, so this is gonna be 6, and over here this can be 20. Look, I'm very sure it can be 20. You see it. Okay, again this is 6. You see it, and this is gonna be 2. And then we have actually 8, which is remaining. So this is what I want, and this is the parameter. You have to actually add all this, you can say these parameters together, so we can have the total parameter, like maybe 24, and then we have 8, which is actually 32, and then we have 2, then we have 6, which is actually 40, and then 20, so we have 60, and then we have 6 plus 2, which is 8, and then 8 over here, so plus 8, and that's gonna be 76. Are you guys there?
Yes, sir.
Is 76 okay or not? Did anybody calculated that? So the number, then the parameter, and then the height, that's going to be the quantity in SFT, okay, or maybe in square feet, right? So this is called the abstract of quantities. We have all these things in the same drawing. There is nothing, I think, more over here in the same drawing. So what's your question? Let me know if there is any confusion. I will even share this drawing with you so you guys can practice it. Let me now just save this drawing and let me just send it to you, okay? And even I'm gonna save this one. All right,
ठीक है सर.
we have almost 20 minutes remaining. So I'm gonna just do this thing quickly, or it was enough. You guys can tell me, okay? What do you guys say? Should I start this bridge work, or it was enough? We're gonna just it's enough, okay? We will cover this thing tomorrow, inshallah.
ठीक है सर.
Okay, Allah Hafiz.